Hello everyone and welcome to the lecture on kubectl daemonset commands. So first we will set the alias k equal to kubectl. Next, how to get all the daemon sets. So the command will be k get ds and this will list daemon sets in the current default namespace. And the output may look something like this. You will have name, desired, current, ready, up to date, available, and the node selector and the age. So this is in days. Next, get all daemon sets. So the command will be k get ds dash capital A. So this will list all daemon sets across all namespaces. And the output may look something like this. You have namespace, name of the daemon set, and desired, current, ready, up to date, available, and the node selector followed by the age. Then describe daemon set. So k describe ds followed by the daemon set name and the optional namespace. So if you omit namespace, it will be default. This will show detailed information about a daemon set, and this is most important debugging command for daemon sets. And the output may look something like this. So you will be shown the name, namespace, selector, node selector, all the information. It's very detailed, like what is the pod, what is the container being used, all the container, the port, host port, environment, volume mounts. So all the information will be shown to you along with any events that it has registered. So it has successful create and these pods were triggered with the pod name. Next, create daemon set. So k create ds followed by the daemon set name that you want, dash image, and then you specify image and which namespace you want to create the daemon set. So this will imperatively create a simple daemon set, and this is good for quick test. And this will be triggering the daemon set, and the YAML may look something like this: API, kind, metadata, namespace, any labels. So this will have labels specific if you have provided any labels, or when you use kubectl create, there is a default label that it gets, and any selector, template, metadata, spec, containers, all those information will be part of the YAML. Next, apply daemon set. So k apply -f and the YAML file. So this will declaratively create or update a daemon set from a manifest file. So this is slightly different. So if it is not there, it will create. Otherwise, if it's already there, the daemon set, it will any changes are there, it will be updated. So next, delete daemon set. So k delete ds followed by the daemon set name and the namespace name. So this deletes a daemon set. The pods managed by it will also be terminated. So edit daemon set. So k edit ds daemon set name and the namespace. This opens the daemon sets manifest in the default editor for live changes. Example, fixing a node selector or toleration. So this will make live changes after you save or edit, save the editor, like the content, it will be immediately applied. So for example, in Unix, it will be opened in vi and the content will look something like this. So there will be a comment and followed by the whole YAML, and you can go to the relevant section searching for it and make the necessary change and save it. It will be immediately applied. So this will have resources, limits, volume, mounts, everything will be part of the YAML. Next, get daemon set YAML. So k get ds followed by the daemon set name and the namespace -o for output and YAML. This retrieves the full YAML manifest of a running daemon set, and the output may look something like this. So same what we have seen in this in edit. So the whole YAML will be, so you can save it, redirect it to a file also, and make changes. You can take a backup and make changes. So it's up to you. Or if you just want to see the YAML, it's easier. So you can use this particular command. Next, set daemon set image. So k set image ds / then followed by the ds name. Then you have to specify the container that you want to update with the new image and the namespace name. So this triggers a rolling update of the daemon set by changing the container image. So this is a sample command, k set image. So ds actual daemon set name. So there is a container name and I am setting it to this particular image and the image tag or the label. So let's say it is 149. I'm setting it to 140, or you can totally change it if you want also, and the namespace name, and you will get a message saying that image is updated. Rollout status of daemon set. So k rollout status ds name -n namespace name. This monitors the status of a rolling update until it is complete, and the output may look something like this: waiting for daemon set, the name of the daemon set, rollout to finish, 0 out of 3 new pods have been updated, and 1 out of 3, 2 out of 3, and finally successfully rolled out. So it will show you the status. If you make an update through, let's say, set image, then you can check out the status history, whether all the images or the pods are successfully updated with the new image. And to check out rollout history of a daemon set, k rollout history, then ds followed by the ds name and -n namespace. This shows the revision history of a daemon set, and this will look something like this. So it will start with revision 1. So when it was first time created, let's say you have updated the image to 140.150, it will keep a record of all the changes that were done. And let's say the last one was through edit, you made some manual edit, so you will see those change history. And let's say you want to do undo, so k rollout undo, so it will just go to the previous last version, ds and the namespace. Here you don't have to specify any image because it will just roll back. So do this rolls back the daemon set to the previous version. So let's say you have just updated the production image or a daemon set and you have some issues, you just run this command, so it will go to the last previous version which was working fine. So you will just get a message when you run this command saying that it has rolled back. And if you want to roll back to a specific version, you can always check out the history and then go to a specific revision version, and then it will be rolled back to that specific version also. So there are two options. Find daemon set pods. So k get pods -n namespace -l. So we are doing a label selector and label key and label value. So this finds all pods that are managed by a specific daemon set using its label selector. That is to find the selector in k describe ds. So first you will do k describe ds, then you will get the label selector, the label, and then you can run this command to find all the pods that are part of this daemon set. And you will see some output like this. Let's say this is the actual command, and you will have all the pods that are part of this daemon set based on the node selector. Label selector, not node selector. Explain daemon set. So k explain ds. So this will show the API documentation for the daemon set resource fields, and output may look something like this. So this is more for understanding how the ds daemon set this object is constructed. So it has API version, kind, metadata, and you will see what is the type. So string metadata is object, and inside that you can drill down what is part of metadata. Then spec is also an object, status is also an object. So this will give you high level fields. Then you will do, if you want to explore further, you will say k explain ds.spec. So whatever you are interested in, you can ds.spec and you can stop here. But if you want to go drill down further, you can template spec tolerations and what values that we have to specify for tolerations. So this drills down to show the documentation for tolerations, a key field for controlling which nodes a daemon set can run on. So this is very specific example, and output for it may look like this. So it is going to a tolerations field, and it has these fields like inside tolerations. In the YAML you will have effect, which is a string, key, which is also a string, and operator, and toleration seconds and value. So if you read the documentation, you will get some more hint on, sometime there is an example, so that may come handy. For example here, right, effect. So it clearly shows that it is no schedule, prefer no schedule, and no execute. So in this way you can, during the exam, you can figure out more information about any specific object. And this is k explain works for almost everything. It will work for pod, deployment, services, all Kubernetes object. This command will work. Explain daemon set node selector. So this is the last example. So k explain ds.spec.template.spec.node selector. So this shows the documentation for node selector. So which node it should run. So node selector, and it has got like node selector specific, and there are fields like there's a map field that you have to specify. So inside node selector you will have a complex object on which node this daemon set should run. Label daemon set. So k label ds name. So we are giving a new label, app version 1.2, and the namespace where the daemon set lives. So this adds a label to the daemon set resource itself, not the pod it creates. So this will go to the daemon set label. So pod also have their own labels. And if you run this command, you will just get a message saying that it is labeled. And if you want to do multiple labeling, you will just run the command multiple times. So we are saying, so this is the same daemon set. And first I'm saying environment production, team platform, and component is logging. So you'll get 3 different messages saying that it is labeled. And that's all. Thanks for watching.